Hello everyone, and welcome back to Learn Math by Example. Today, we're diving into the fascinating world of sequences and specifically how to define them using recursive formulas. What exactly is a recursive formula? Now, a recursive formula defines each term of a sequence based on one or more preceding terms. Now, instead of giving you a direct way to calculate any term, it tells you how to get from one term to the next. Crucially, a recursive formula must always be accompanied by an initial condition. This specifies the first term, or sometimes the first few terms, to kickstart your sequence. Without it, you wouldn't know where to begin. You'll often see them in general forms like u of n is equal f of un minus 1, where the current term un depends on the immediately previous term un minus 1. This recursive relationship is referred to as a first-order recursive relationship. For more complex sequences, u of n will be a function of un minus 1 and un minus 2, where un depends on the two terms before it. Remember, n typically represents the term number and is a positive integer. It's always a positive integer. Now, let's practice finding recursive formulas for various sequences. Our key hint here for all these problems is to identify the pattern between consecutive terms. Always check for differences, ratios, or more complex relationships. Let's start with part A. Now, consider the sequence 5, 8, 11, 14, etc. To find the pattern, let's look at the differences between consecutive terms. From 5 to 8, we add 3. 8 to 11, we add 3. And 11 to 14, we also add 3. So this is a constant difference of 3, which tells us that this is an arithmetic sequence. So to get to the next term, you simply add 3 to the previous term. Our recursive formula in this case is un is equal to un minus 1 plus 3. And remember, we need an initial condition. So the first term here is u1 equal to 5. So we write u1 equal to 5. Together, this is completely defined the sequence recursively. So keep in mind, we need the general term and we need u1. Now moving on to the next one, we have 2, 6, 18, 54, etc. Again, let's look at the pattern. If we check the differences, they are not constant. 6 minus 2 is 4, 18 minus 6 is 12. So it is not an arithmetic sequence. Let's try ratios. 6 divided by 2 is 3. 18 divided by 6 is 3. 54 divided by 18 is also 3. So we have a constant ratio here. This indicates that we have a geometric sequence where each term is found by multiplying the previous term by 3. So the recursive formula is un equal 3 times un minus 1. And our initial condition for this sequence is u1 equal 2. Simple, yet powerful. Now finally, for the last one, let's look at a slightly more complex sequence. Now the sequence is 1, 3, 7, 13, 21, etc. Let's find the differences between consecutive terms first. These are called the first differences. We have 3 minus 1 equal to 2, 7 minus 3 equal to 4, 13 minus 7 is 6, 21 minus 13 is 8. So the first differences are 2, 4, 6, 8, etc. This is not constant, so it's not arithmetic. But notice a pattern in these first differences. Let's find the difference of these differences, which is called the second difference. We have 4 minus 2 is equal to 2. 6 minus 4 is 2. 8 minus 6 is also 2. A constant second difference indicates that the first differences form an arithmetic sequence, and thus, the original sequence is quadratic. The first differences are 2 into n minus 1 for n greater than or equal to 2. Meaning that the difference between un and un minus 1 is 2 into n minus 1. Therefore, we can write a recursive formula as un equal un minus 1 plus 2 into n minus 1. And of course, our initial condition is u1 equal 1. This covers a more advanced type of pattern recognition. To summarize, recursive formulas are a powerful way to define sequences by relating terms to their predecessors. Always remember to include the initial condition. Whether it's a constant difference for arithmetic sequences, a constant ratio for geometric sequences, or pattern in the differences for more complex sequences, careful observation is your best tool. Keep practicing these patterns and you'll master recursive formulas in no time. Now that we've learned how to find a recursive formula between two terms, let's move on to finding recursive formulas between three terms. This is often referred to as a second-order recursive relationship, as each term depends on the previous two terms. Typically, these formulas take the general form of un plus 2 equal a times un plus 1 plus b times u of n. Here, u of n plus 2 is defined by the previous terms un plus 1 and the term before that un. Sometimes you might see it as un equal to a times un minus 1 plus b times un minus 2. So our goal is to find the coefficients a and b. Here are some key hints for tackling these problems. Firstly, you'll need at least 3 consecutive terms of the sequence to set up enough equations. Secondly, these problems almost always boil down to solving a system of linear equations. Finally, remember that for the IB exams, the focus is on your problem-solving skills and algebraic manipulation, as direct formula for A and B aren't explicitly provided in your formula booklet for this type of relation. Let's work through an example. Consider a sequence whose first 4 terms are 1, 2, 6, and 16. Assuming this sequence follows a recursive relationship of the form un plus 2 equal a times un plus 1 plus b times un, our task is to find the values of a and b. Okay, this is what we're going to do. Step 1, start by writing down the general form of the recursive formula. So we have un plus 2 is equal a times un plus 1 plus b times u of n. Now we form our first equation by using the terms u1, u2, and u3. So when we set n equal to 1, this gives us u3 is equal au2 plus bu1. Substituting our values 1, 2, and 6, we get 6 equal to a plus b. In step 3, we form our second equation now. We use the terms u2, u3, and u4. By setting n equal to 2, this gives us u4 is equal a times u3 plus b times u2. Now, replacing u2, u3, and u4 by their corresponding values, we get 16 equal 6a plus 2b. Now we have a system of two linear equations with two unknowns. We have 2a plus b is equal to 6, and the second equation is 6a plus 2b equal to 16. Now to solve this, we're going to use the elimination method. Multiplying equation 1 by 2 to get 4a plus 2b equal to 12, now we can subtract these two equations to get 2a is equal to 4, which means that a is equal to 2. Now in step 5, with a equal to 2, we can substitute this value back into equation 1, for example, to find b. So 2 times 2 plus b is equal to 6, which gives us b is equal to 2. Now finally, we state the complete recursive formula by substituting the values of a and b back into our original form. So the recursive formula for this sequence becomes u of n plus 2 is equal to un plus 1 plus 2un. And there you have it. Finding recursive formulas between three terms often involve this systematic approach of setting up and solving simultaneous equations. Keep practicing and you'll master this skill for your IB exams. If you have any questions, feel free to comment below. You can also leave a comment on our website. For more practice, please visit our website. The link is in the description below. Our next lesson will be about arithmetic sequences. Thank you for watching and see you in the next lesson.